Okay, hi everyone. Today I'm going to be talking about embracing change and how you can embrace change but also take precautions. So this talk is about policy as code in Kubernetes with Gatekeeper. Thanks for organizing this amazing conference. The venue is amazing. It's like I'm overwhelmed by the views and everything, so thanks for that. So yes, I'm a developer advocate at Datadog. Most of my career also system engineering, Linux, containers, Kubernetes, etc. I live in Malaga, Spain. So if you have any want any recommendations, if you're visiting anytime, please reach out. For any other things also about Kubernetes or containers, you can reach out to my email and my Twitter. DMs are open, so if you want to ask questions as well. Few words about the company that employs me. Datadog is a monitoring and security platform that helps companies improve observability and security of their infra applications. That includes, of course, Kubernetes and the apps that you run on top of Kubernetes, of course. We are hiring across the board, so if you have any questions about what's like working at Datadog, please reach out. We just opened a new office in Lisbon, so that's also a nice perk. There are also a lot of remote options, so again, any questions, I'll be here today all day, tomorrow until more or less lunchtime, so please reach out. But today I'm going to be talking about policy, which is kind of a dull topic, but I hope I'm going to make it a little bit more interesting. So what is policy when we talk about software? So policy is basically the rules that governs the behavior of a software service. Basically, what you can and cannot do with software. And if you think about what you can and cannot do with software in Kubernetes, this sounds a lot like RBAC. So if you've used Kubernetes, you're familiar probably with role-based access control, which is basically what you can and cannot do with Kubernetes. So how does RBAC work? So RBAC basically has a subject, a Kubernetes API resource, and a verb, and you make combinations of those things. So, for example, you can make a combination saying that a user called Ara, it can be a user, it can be a service account, for a particular object in the Kubernetes API realm, like a pod. She can create, get, and watch those resources in a particular namespace or across the whole Kubernetes cluster. So these kind of things that you can do with RBAC, and it's basically more or less that, which you can and cannot do with Kubernetes. So why I'm doing a talk about something else? And the reason is because RBAC only covers a certain amount of auth, and policy, it's a lot more. So if you're running a platform in a company and you want to give your developers like flexibility to run their own applications in production, observe them in production, etc., they may not be as familiar with Kubernetes as you are, so you need to put some guardrails to help them achieve their goal without breaking some things. So what are the type of things as a platform engineer that you can think about, of type of rules that you would like your developers to follow? So these are the type of questions that you cannot answer with normal RBAC. Like things like, can I run an image coming from a third-party registry? This is something that your developer may or may not know if they're able to, and you want to create some policy around it. Or has my pod all the labels that are required by my organization? That's another thing that you cannot do with RBAC. Basically, on RBAC, if you can create a pod in this namespace, whatever inside that pod is outside RBAC. So we want to create policy for Kubernetes. These are the type of rules that we want to create. But probably our stack is not only Kubernetes. We may have service meshes, we may have gateway APIs, cloud services, we may have stateful applications like Kafka, all these things. So you want to create policy for many, many different things. So if you have to know how to create policy for many different things, it's a little bit cumbersome. So that's where Open Policy Agent, which is a CNCF project, so part of the Cloud Native Computing Foundation, tries to solve. So it tries to decouple policy from definition of policy and decision of that policy to implementations, to enforcement. How does it does that? So basically trying to, again, decoupling completely enforcement of that policy with policy decision. So when you want OPA to make a decision about a policy, like I'm a developer, I want to do something, can I do it or not? Basically, what you send OPA is a JSON file. And OPA has two things to make a decision. They have the policy, which is written in a specific language called Rego, and some data that can be stored in JSON as well. And it returns a JSON, so it's completely domain agnostic. So it receives JSON, it returns JSON, and after that, enforcement is completely outside this core of OPA. So how do you enforce a policy decision? So you do that through a lot of integrations that OPA has. So it has a lot of integrations that understand how to translate something into an OPA query and how to enforce an OPA result for a particular piece of software. And this is what Gatekeeper is. Gatekeeper is an enforcement of OPA policy for Kubernetes. And the way it does is that it embeds OPA library inside a controller in Kubernetes, and it's able to then enforce the policy that you may want to write. So how does Gatekeeper enforces policy? So when you make an API request to Kubernetes, one of the great things about Kubernetes and one of its great successes is that everything is API-driven. So everything that you want to do with Kubernetes, you may basically do an API request to the API server. So that API request, it goes through phases. The first one is authentication. Is this authenticated or not? Probably you want all your requests to be authenticated. If it's authenticated, then it goes through auth, so RBAC. So can I create a pod on this particular namespace, for example? And if I can, it goes through a third phase, which is admission controllers. And admission controllers are small pieces of code that are embedded on the API server that can do a little bit more about that API request. They can further validate their API requests based on a set of rules and even mutate them. Like it can change the API request if we want to. All those pieces of code are, again, embedded on the API server in Kubernetes. But there are two special ones that more or less are always enabled by default in any Kubernetes distribution, which are validating admission webhook and mutating admission webhook, in which you basically can tie in external code on that admission controller phase of the API. So that's where Gatekeeper is. Gatekeeper hooks into those hooks and basically is able to create pieces of code that are going to go through that phase of admission controllers. Why is Gatekeeper so successful so far? So Gatekeeper is actually the third generation of OPA enforcement in Kubernetes. Actually, it's a little bit strange because if you go to Gatekeeper GitHub, it started with version 3.0, which it's super confusing. It's like, where is 2.0 and where is 1.0? And the reason why they started with 3.0 is because it's the third generation of enforcement in Kubernetes for OPA. And the reason why this is probably the one that is going to stay for a while is because they designed it from the ground up as Kubernetes native. And what I mean that they are Kubernetes native is that they implement this classic design pattern in Kubernetes of the reconciliation loop, of creating new extensions to the API, new CRDs, custom resource definition, so extending the API, and then having a controller watching all the time for those resources and make adjustment to the cluster based on that. So what are the main extensions of the API that it creates? So these are for validation. So on this talk, I'm going to be focusing on validation. From Gatekeeper 3.7, you can also do mutation. But for validation, which is the first thing that probably you want to do, you have two things. So you have an object called constraint template that where you define with parameters the set of rules, but then you can instantiate that many, many times into different rules by saying those parameter values. So how does this look like very, very high level? We are not going to be very specific about Rego code, but this is more or less an example of a constraint template. So you can see it's an object, a Kubernetes object. It has a name, required labels. It has a set of parameters. Probably you cannot see it from the back, but in this case, it gets an array of strings, and then you get a bunch of Rego code. This constraint template is just a template. It doesn't enforce anything yet on your cluster, and we are going to see that on the demo. You have to instantiate that into different constraints. And the good thing about this is that you can reuse the same Rego code over and over again for completely different rules. So these are two different constraints. On the left-hand side, you can see that all namespaces require the label gatekeeper. That's a rule. And a completely different rule with the same Rego code, with the same template. Here on the right-hand side, we say every pod in the default namespace required to have the label do not delete. And those are two different, very different things, different objects, different namespaces, etc. But we are reusing the same code, which is great. And that makes Gatekeeper great for policy reuse. It makes it very, very simple to reuse policy that inside the same organization. So in this case, we've seen two different rules that you may apply on your organization, but also across organizations, because probably the type of rules that you want to create in your clusters are very similar to the type of rules that all the people already thought about putting in their cluster. So to put examples of things that you can do with Gatekeeper that it's very, very common, images can only come from approved registries. That's a given. Like, you cannot just download an image from random registries that haven't been passed our security, for example. Or deployments required to have certain mandatory labels, as we saw. Container images must have a digest. That's another one. You want to know exactly what image you're downloading, not just latest, for example, or a random label. Containers must have memory and CPU limits set and within a specified max value. So you can see that these are type of rules that we are very common. Obviously, the specifics to that rule are very specific to your organization, but many of these rules have common things to all orgs. And that's where this is super useful, and we are going to see this in the demo. Gatekeeper comes with a Gatekeeper library, which contains a lot of templates for you to start using Gatekeeper with common rules that are very, very common. And the Gatekeeper library, it's super well done that for every type of template, you have a template. In this case, for example, template for this one is for ingresses only being HTTPS. So in the library, you will see that you have a template, but also you will have examples of instantiation of that template, and also examples of objects that may pass or fail that particular constraint. So even if you don't know Rego, and if you're going to use Gatekeeper very, very hardly on your organization, at some point you will need to learn Rego to make changes. But to start with, just using the library and understanding with those examples what a rule does and how to instantiate that rule and how to fail or pass that rule, it's going to give you enough information to get you started. So the Gatekeeper library is under the Open Policy Agent, GitHub. Also, Gatekeeper is there. So go check it out. And before the demo, I want to put another example of validation rules that are a little bit different. Remember when we were saying that OPA make that distinction or make the decision of the policy based on the code, Brego, but also some data that you may store in OPA. And this is a type of rule that requires some data. So if you want to create a rule that says a host must be unique among all ingresses, to make that decision, OPA doesn't only need the object that you want to create. You also need all the objects that are already as ingresses in your cluster. And this is where that data comes from. So again, Gatekeeper makes it very, very simple to allow you to decide what objects you want to store. You don't want to store all your cluster. You have etcd for that. It would be a duplication. It would be very, very hard to make decisions quickly. So if you want to create a rule like this one, you can tell Gatekeeper through a new object called config that you want to store all ingresses. Basically, you create that object, and the Gatekeeper controller is going to start downloading all of the ingresses that you create so you can make those decisions afterwards. Another great thing that I really like about Gatekeeper, they really, really thought about observability and monitoring from the ground up. So it comes with a lot of out-of-the-box metrics that are super useful, like the number of constraints, templates and constraints, the number of requests, both validation and mutation, and the latency of those requests, the number of violations, the number of resources that we have cached thanks to that config. And we have also Datadog integration based on those metrics. So if you're using Datadog, that will come out of the box. I created that integration, so if you have any complaints or just open an issue, happy to get bug reports there. So we are going to move to the demo. And let's do this. Let's open this here. Let's move this down. Okay, I'm going to keep everything hopefully at the top of the screen, because I know from the back it's a little bit difficult to see. So is the font size big enough? Okay, good. So I'm running a local cluster in kind. So I have a couple of nodes, a working node, a control plane node. I'm running Gatekeeper in a namespace. So you can see that we have 3 controller managers pod runnings. And the reason why is the default, I'm using just the default deployment of Gatekeeper. It runs by default on high availability mode. So if one pod goes down, you still have a couple of them. And the reason why is everything is down. So if you only have one pod of the controller manager and it goes down, basically anything goes. So it doesn't block anything, like everything goes. And then you have another one, which is called the audit one, that we will see in a second what it's for. And I also have running Datadog here. So as I said, Datadog is going to be collecting also all the metrics that we were talking about here by default. So it's basically understand that Gatekeeper is there and start running. Cool. So let's do something. One of the things that I want to do is to make this very, very simple and just use the Gatekeeper library that we saw. So we see here a bunch of templates. And we are going to do the required labels ones, which is pretty simple and easy to understand. And you can see when, basically when you clone the Gatekeeper library, for each of the rules, you will have a template. Suite.yaml is internal, is for their own testing. Then you have some customization if you need to. Usually it's not needed. And a set of samples. So the template looks like this, as we said. It has a description. So again, super easy to understand what a rule is intended to do. The new kind of object it will create, a set of parameters with the explanation of what it does, and the Rego code. So Rego, by the way, is a declarative language. It's not imperative. So if you've never used declarative languages at the very beginning, it's a little bit difficult to understand. But once you get the hang of it, it's pretty simple because, again, the input is JSON, the output is JSON, nothing else. And they have a very, very good website to test any of your Rego. OK, so the first thing that we need to do in our class day is to apply that template. And again, once we create the template, we are not yet enforcing anything. It's just a template. But one of the things that it does, it creates a new object. It's this one here. So now I can create objects that has that type. So it creates a new, it's a little bit, everything a little bit meta. So I could create a constraint template that creates another CRD. And because I have samples, I can use those samples to create my own rules instead of just seeing. So I'm going to copy this sample. And let's call it all must have DevOps days, for example. And let's open this. And it has a constraint. And the original one was called all must have owner, so let's change the name. Let's say, instead of namespace, let's say pod. And I say all pods. This is the message, by the way, that will be returned to the user that tries to do something that is not allowed. So I want, as a cluster administrator, I want to make sure that the rules that I create give enough information to my users to fix their issues. So I can say, OK, your pods must have a DevOps labels. And let's imagine that we don't care about the value. We only care about the key. So let's remove the allowed regex and just say here DevOpsDays. Let's save that, and let's apply that. All must have DevOps, constraint. And this is now created. So now, in theory, I'm creating a rule that says all new pods require to have this particular label. So let's give that a try. We have here a pod, an Nginx pod, simple, that doesn't have that label. So let's try creating that one, and let's see if the demo gods are with me. Good. Let's do it again so we clear this so it's up there. So it gives me enough information as a user. It says, error when creating that Nginx pod, the admission webhook, the validating one, not the mutating, denied the request. Because of this rule, the all must have DevOps days, and the message to the user, all pods must have a DevOps day label. Okay, so now as a user, I can say, okay, let's fix that. I can create a new rule that's a new label, DevOpsDays. And it doesn't say anything about the value, so let's just say Portugal. And now let's try that again. And now the pod, it's created. So you can see it's super simple to start creating rules that are understandable, that are reusable in your cluster. One of the things that before we move on, gatekeeper system. When we were saying the pods, we saw that controller. The controller is the one that does the enforcement. But we saw this audit pod. What is this for? So we have created a new rule that says all pods need to have this particular label. But we already had some pods running that didn't have that label. What happened to those? Gatekeeper doesn't delete them, obviously, because if not, you won't be able to start adding new rules. But you are able to know which ones are violating that rule. So if you get the constraint that you have and describe it, one of the things that it's going to tell you is all the pods that are failing this rule that are already running, because they were running before. So that way, you're able to see what things need to be fixed in order to follow that rule. So obviously, all the information is going to be appearing here if you're running Datadog, like policy violations. If you're an admin, you're able to know how many constraints, et cetera, which as an admin can be useful. But again, many of the metrics, not all of them, but many of the metrics are out of the box. So if you're using Prometheus as well, you can export them to whatever you're using. And yeah, that was the demo. So that was the demo, and actually that was the talk. So thanks a lot. Thank you. So if you have any questions, feel free. Go ahead.
Perfect. We already have some questions.
Yep.
There we go.
Hi. Hello?
Is it on?
Okay. Hi. So, great talk. But one thing that can be a little bit annoying is the fact that when we have a big pipeline and the developer only see that arrow at the end.
No. Very good question. So,
but the thing is, one thing that I want to raise is that I see that Rego can be used in several places. Is it possible to package that Rego policy and put at the beginning of pipeline and try to use it? Because we already use OPA and Rego, but in a different scenario. So basically, we already write our policies in Rego, and we have built a CLI that use that Rego policies and OPA to check everything. But we never put it in the gatekeeper. Did you already have that experience of replicate in the beginning of the pipeline, at the end of pipelines, just to make sure that developers doesn't do it? But if someone try to access my Kubernetes cluster, also doesn't do that violation of the policy?
very good question. I think the question is that this is the demo where we saw everything was happening already in a production cluster, like too late. Yes, you can add this to a pipeline. So one of the, I actually have a blog post on how to add this to a pipeline. So there are two things, two ways. There is a specific library for Rego, to test Rego, that is very, very, very basic, not gatekeeper at all, like just testing. You can basically test the YAML definition against some Rego policy, which is obviously faster. That's a way to do it, and that's one of the ways, like the gatekeeper library is testing their own ones. The other way, which is the one that I explain in my blog post, is to create part of your pipeline more end-to-end testing of creating a small kind cluster that basically, for any GitOps object that you have the new changes, it creates quickly a new cluster, applies the policy, and then tests against all the objects that you have. So there are two ways. So one would be more at the beginning of the pipeline to make sure that the YAML definition against the Rego is correct, and also to test Rego itself, because obviously one of the things that you need to do not only is test the objects against the policy, but also test the policy itself. So I would recommend using that library at the beginning, but also for an end-to-end test at the end, you can do it with kind clusters.
Okay, thank you.
Okay, any other questions? Still have time for one more. Yeah, don't be shy. Like, it's important to have these questions for sure, but feel free to also reach out to Ara afterwards. And if you have any questions afterwards, we can also add them to the open space topics, okay? Still not a lot of topics there, so feel free to also share questions there. Like, we can get our speakers in the rooms if we need to, okay? One more question there.
Okay. This might be a little simple question, but I'm kind of new to Kubernetes. So after applying those labels, we saw that we have like 17 errors. Is there any way to quickly apply, let's say it's a small change, and you want to apply the label for every pod that you already have? Is there any way to do a mass apply into all those pods, or you have to go one by one?
I don't think I understand the question. Can you?
So after you applied the label,
Yes.
You now have 17 errors because you have pods that don't have any label. The way to fix is to apply that label into all the pods.
Yes.
Is there any way to, like, in one run, apply everything to all pods, or you have to change one pod at a time?
So it depends on how you manage your Kubernetes objects. So if you, in theory, like, you would have everything in Git, and you can, for example, create a small applications, small scripts that will add that label. So one of the good things about Kubernetes objects, although we use YAML because it's easier for humans, although some people don't agree with this, but in theory, YAML is easier for humans. It's also JSON, so you can, using any of the JSON changes, JSON tools that you can add, you can apply that. Obviously, if everything is on Git, you apply that change, and hopefully we'll create a PR that will be reviewed by a human before you push to production. That would be my recommendation.
Thank you.